Let's practice solving quadratic equations by completing the square together. For number 1, we have this equation here of x squared plus 10x plus 1 is equal to 24. Alright, so first thing we're always going to want to do is get all the constants to the same side. So we're going to go ahead and subtract 1 from both sides of the equation to get it to the right side. Once we subtract 1 from both sides, we're going to just have this x squared plus 10x on the left side of the equation. Now I'm going to leave a little blank here because we're going to have to complete the square in just a moment. And on the right side, 24 minus 1 is 23. Okay, so to complete the square here, what do we have to do? We have to take this b term of 10. So we're going to take this 10 and take half of it. You take half of it and then square it. So half of 10 is going to be 5. 5 squared, that's going to be 25. So 25 is going to be what completes the square here. So if we add 25 on the left, we should add 25 on the right. Okay. On the left side, we should be able to take this and factor this into a perfect square trinomial, which is really just going to be two identical binomials of the quantity of x plus 5 times the quantity of x plus 5. On the right side, 23 plus 25 is going to be 48. On the left side, we can go ahead and condense this into the quantity of x plus 5 squared is equal to 48. And then what we can do here is we can go ahead and take the square root of both sides of the equation so that we can get rid of that squared symbol, right? So that's the inverse of that. So we're going to have the x plus 5 on the left is equal to plus or minus the square root of 48. Now on the side here, you want to remember that 48 we can break into, the square root of 48 we can break into the square root of 16 times the square root of 3. 16 is the biggest perfect square inside of it. So we can, the square root of 16 is 4, so we're going to get 4 root 3. So we can just write here x plus 5 is equal to plus or minus 4 root 3. And then finally we can subtract 5 from both sides of the equation here. And if we do that, then we can say that x is going to be equal to the negative 5 plus or minus 4 root 3. Those would be our two solutions here. Here's number 2. For number 2, we have this equation of x squared plus this 2x plus 37 is equal to 0. So just like in number 1, what we're going to do first is take away 37 from both sides of the equation. So we can get the constants to the right and then our x terms to the left. If we do that, we're going to get x squared plus 2x. Let's leave some space because we're going to complete the square. And on the right side, 0 minus 37 is going to be negative 37. Okay. Now for completing the square, look at this b term. This b term is 2. So again, how do you complete the square? We take b, we take half of it, and then we square it. All right, so half of 2 is going to be 1, and if you square 1, that's going to equal 1. So that's going to be the value that completes the square. Let's go ahead and add 1 to both sides of the equation. Now, on the left side, we have a perfect square trinomial now, so we're going to have this quantity of x plus 1 times the quantity of x plus 1. And on the right side, negative 37 plus 1 is going to be negative 36. On the left side, let's go ahead and condense this. So we just have this x plus 1 quantity squared is equal to negative 36. And then to go ahead and get rid of that squared, we go ahead and take the square root of both sides of the equation. On the left side, we're going to have this x plus 1. And on the right side, we're going to have plus or minus the square root of this negative 36. Now, when thinking about the square root of negative 36, what you want to do is separate that into the square root of negative 1 multiplied by the square root of 36. And remember that the square root of negative 1 is I, and the square root of 36 is 6. So we're going to get 6i here. So going back to our equation, we can say this is x plus 1 is equal to plus or minus 6i. And then taking away 1 from both sides of the equation, we're just going to have at the very end here that x is equal to negative 1 plus or minus 6i. Those would be our two solutions here. Here's number 3. For number 3, we have this equation of 3x squared is equal to 3 minus 42x. Now again, we want all of our x terms on the same side and just our constant alone. So let's go ahead and add 42x to both sides of this equation. So we have the x terms all on the left side, and then we can leave that 3 alone on the right side. So once we add 42x to both sides, we're going to get 3x squared plus 42x on the left side of the equation. and then we're going to have this equal to 3 on the right side of the equation. Now at this point you want to notice that we have this coefficient of 3 in the beginning, and we really don't want that. So we should factor out if we can, or we can notice here that everything in this problem is divisible by 3. So we can make our lives a little bit easier if we just divide everything by 3. So 3 divided by 3 is 1x squared. 42x divided by 3 is going to be positive 14x. I'm going to leave some space to complete the square, and then 3 divided by 3 is 1 on the right side. Okay. Now to complete the square, let's look at this b term, or b value of 14. Take that 14 and cut it in half. Then let's go ahead and square it, right? So half of 14 is going to be 7, and then if you square 7, that's going to be 49. So if we go ahead and add 49 on the left side, we should add 49 on the right side, and that has completed the square. Okay. On the left side, this is going to factor into two identical binomials, x plus 7 and x plus 7. And on the right side, 1 plus 49 is 50. Condensing the left side into the quantity of x plus 7 squared, and then the right side we can keep as 50. What we can do next is take the square root of both sides of the equation. Okay, so on the left side we'll have just x plus 7, and on the right side we have, let's see, the square root of, we have plus or minus the square root of 50, right? But for the square root of 50, let's see, I think we can say the square root of 50 is equal to the square root of 25 times the square root of 2. The square root of 25 is 5, and then root 2 is going to stay as root 2. So we can go ahead and say, if we simplify that radical, we're going to get plus or minus 5 root 2. And then we can subtract 7 from both sides to get our most simplified answer here, and say that if we go ahead and subtract 7 from both sides, that x is equal to negative 7 plus or minus 5 root 2. These would be our two solutions for this equation. Here's one more. For number 4, we have the equation 5x squared minus 30x plus 85 is equal to 0. And before we even go ahead and move anything, I notice everything is divisible by 5, right? So let's divide the entire left side by 5 and divide the right side by 5. So if we do that, 5 divided by 5 is 1, so we're going to get x squared. And then negative 30 divided by 5 is going to be negative 6, so minus 6x. 85 divided by 5 is going to be 17, so plus 17. And that's going to equal what 0 divided by 5 is, which is still 0. Next, let's go ahead and subtract 17 from both sides of the equation. Basically just moving that constant, or that c term, to the right side. Left side, we're just going to still have this x squared minus 6x. I'm going to leave some space to complete the square, and then on the right side, 0 minus 17 is negative 17. Now this b term is negative 6, so to complete the square, let's take half of that negative 6 and then square it. So half of negative 6 is negative 3, and then negative 3 times itself is going to be positive 9. So to complete the square here, let's add 9 to both sides. If we do that, we get a perfect square trinomial on the left, so this is going to be x minus 3, and we have 2 of these binomials. And on the right side, negative 17 plus 9 is going to be negative 8. Condensing the left side into this x minus 3 quantity squared is equal to negative 8. We can then get rid of that squared symbol by taking the square root. So let's do that to both sides of the equation. Doing that, we're going to get x minus 3 on the left side, and on the right side, we're going to get plus or minus the square root of negative 8. Now, thinking about that square root of negative 8 on the side, again, if we have a negative value inside, we can separate this into the square root of negative 1 times the square root of 8. The square root of negative 1 is going to be I, but then the square root of 8 has a perfect square inside of it, right? So we can break the 8 into a 4 and a 2, and the square root of 4 is going to be 2, so we have I times 2 times the square root of 2, and then we can just rearrange this as 2I root 2. All right, so that's a square root of negative 8, so we can write x minus 3 is equal to plus or minus this 2I root 2, and then finally add 3 to both sides of the equation to completely isolate x. And if we do that, we're going to end up with x is equal to 3 plus or minus 2I root 2. These would be our two solutions. So there you have 4 different practice problems on solving quadratic equations by completing the square. If you found the video helpful, please consider giving it a thumbs up, and as always, keep up the great work, and I'll see you in the next one.